Hi, I'm Jerry McCallum. I work for Bornquist Inc. We're the Bell and Gossett rep for the Chicagoland area. I'm the sales guy, but I spend a lot of time in the boiler field working on boilers, mostly commercial, but I do get involved with residentials occasionally. In a prior life, I was in marketing for residential boiler control, so I have a pretty deep knowledge of the different types of boilers out there and stuff used on them. So we'll get started here. One of the things we first want to talk about, obviously, is, a boiler, you have to service it periodically if you want to keep it running properly. And we do it for many reasons. Sometimes it's for internal reasons where we want to treat the water, make sure the water is good, and make sure the controls are working properly. There's ways of testing the controls, the safety devices that are on there, the operating controls and all that, to make sure they're working good. And then there's the flame side, where the burner is. And, we want to make sure that's maintained and looked at annually. Basically what they're going to do is they're going to, not unlike a car, they used to, back in the day, stick that little tube up the exhaust to monitor the exhaust quality. Same thing with boilers. They have devices that they use to do that. And the idea behind that is because if you let the boiler get really dirty on the flame side, the biggest issue that we're all concerned about is carbon monoxide poisoning. Because if that boiler gets plugged up enough, you actually can create an unsafe condition that you can, hurt yourselves, or hurt the occupants of the building or whatever. So be very, very cognizant of that. There's boiler types. There's several classifications. By type, there's either steam boilers, which there's still quite a bit of steam boilers here in the Chicagoland area. But for the most part, besides Chicago and maybe New York and some other older cities, that have been around for a while, there's not a lot of steam. Okay, most of it's going hot water. And any new construction, if they're going to put a boiler in, it's rarely or very unlikely it'll be steam. It's going to be either hot water or some other form of heating. So hot water is definitely your more. What's that? Well, that's not what I'm talking about. I'm not saying you can't. In a situation like that, they're probably going to put another steam boiler in. That's the most efficient. If that system is designed well and is maintained well, and it hasn't had a whole lot of people working on it and changing and rearranging furniture as the piping and all that, it's fairly efficient. Steam boilers are fairly efficient, even compared to hot water. Hot water boilers are typically a little more efficient, but they're not bad. It's not a huge difference, and so in a situation like that, to convert to hot water is very difficult. So it's done, but it's very rare that it'd be done. And also, just so you know, if you ask a question, you get a hat. Would you like a hat? You got a stocking cap or a baseball cap? What would you like? Can you pass that back to the gentleman? One hat per person. Of each. Okay. I'll work with you there. Category of boilers. Atmospheric is your typical boiler that you're probably going to see in a residence where the flame's underneath. They have the big hood. Sometimes there's a big bell cap on top of it for the excess air to get pulled up to the chimney. There's no fan blowing on the boiler. It's just a natural lifting of the heated air. That flue gas that actually pulls the flue gas up and out of the building. That's called an atmospheric boiler. Forced draft is there's actually a little fan in the boiler that's pushing the air through the boiler. But that means that usually you're going to have sealed piping, and that's where where your boiler is a little more high efficient. That's where you might see that plastic PVC venting, or or the smaller venting stainless steel, because these types of boilers are typically modulating. They're the ones that you can, when they say I'm installing a high efficiency type boiler, that's what they're talking about. It's not going to be your atmospheric, because your atmospheric is going to run right around 80% efficient, whereas a modulating hot water boiler can get well into the high 90s on efficiency. But with that, it's usually a condensing boiler, and I'm not going to get into that because that's not what we're really talking about here. But I'm just saying that's when they talk about high efficiency type boilers, that's what they're talking about. And the burner arrangement is just what I was just talking about by category. It's atmospheric or power type burners. But like I say, they come in different flavors. You know, there's a lot of boiler makers out there that are making boilers, and I don't say any one's better than the other. You know, I mean, if you're in the industry right now and you're selling boilers into the industry, you're probably selling a piece of equipment that's pretty good, because you wouldn't be in business, and it's not the business for the faint of heart. So most of the boiler makers out there are doing a pretty good job. But they do come in different styles, okay? And some of them are cast iron. These are your old cast iron steam boilers. Even water boilers you can get in cast iron. And these are probably the type of equipment that was put in a building that was built 40 or 50 years ago. They still make them. They've gotten smaller. I will say that. So like if you're gonna get a cast iron boiler replaced, odds are it's gonna be considerably smaller. They call it a footprint. Have a smaller footprint than the one that was there. Don't be concerned, because they're designed for a certain BTU rating. So that boiler that was there before that was big could have been 100,000 BTUs. The boiler that they're putting in now is gonna be smaller, but still 100,000 BTUs. So it's gonna do the job heating your building. If they know it, if they know how to calculate it, yes. You know, and if they, but well, typically what happens with the replacement boiler is a guy's going to walk in, he's going to look at the nameplate of the boiler that's there and say, okay, I'm going to get you one that size. Or if they don't have one that fits that size, maybe a little bigger. They're not going to go smaller, which may be the wrong way to go, you know, because you may not necessarily need all that. Because if you really think about it, today's buildings compared to buildings of 40 years ago are sealed up a lot tighter. You know, they're a lot more efficient. The lighting's more efficient. Plus, you have a lot more heat emitters inside your building, like computers and stuff like that wasn't there 30 or 40 years ago. That actually. No pilot lights. What's that? No pilot lights. Light bulbs are cooler. Well, that's what I'm saying. So there's a lot of stuff that makes the building require less of a heat load, and the furnace or the boiler downstairs probably hasn't been changed to accommodate that. But that's just, you know, that happens. There's steel tube boilers, there's copper fin boilers. These are just the way they're designed. Rather than being cast iron, these are actually steel tubes, and they run the heat past the steel tubes. Or sometimes the water's on the inside, sometimes the water's on the outside, depending on whether it's water tube or fire tube. Copper boilers, there's copper boilers out there. Often these are often used in water heating, domestic water, but they're pretty efficient. They heat the water really fast, but you got to watch your flow, because they require a lot of flow, because the copper, if you don't get the proper water flowing through it, you can overheat the copper and actually melt it. And then I did already touch on condensing boilers, which are the latest craze in the industry. The boiler industry, I remember when I used to teach back many, many years ago, I always said the boiler industry moves at a glacial pace. I mean, it hasn't changed much in the last 50 years. Well, I'm happy to say now, in the last 15 years, it's probably has changed more than it has in the prior 50. I mean, it's really, and a lot of that is technology that's coming over from Europe, and that's because of their fuel. Their cost of fuel in Europe is a lot more expensive. Here, natural gas used to be expensive, but it seems like nowadays even natural gas isn't that expensive, but it's still an expense. And if you're heating a building, particularly if you're a building owner, and depending on how you have your contract set up, you want your building to be as efficient as possible.
Are these interchangeable?
What's that?
These boilers, can you change one out for the other?
It depends on the application. A steam boiler, no. A steam boiler is a steam boiler. Water boilers, which is what we're talking here. Now, a steel tube boiler can be a steam boiler. you don't see it so much on the residential side. It's more on the commercial side. You know, a copper fin boiler will not be a steam boiler. It's going to be a water boiler. And same with condensing boilers. There is no such thing as a condensing steam boiler. So that'll be a water boiler. But you can, if you have a cast iron water boiler, you can use a condensing boiler in it, but I didn't want to get into this conversation too deeply because it's kind of complicated. But you're not going to save any money unless you can drop your water temperatures in the building down. So you're running cooler water temperatures. It's the only way you can condense. You won't condense. If your set point's 180 degrees, you're never going to condense, and there's no reason to have a condensing boiler because it's only going to run at 87% just like your non-condensing boiler, and you spend extra money for something you're not going to use. All right, and I really don't want to get into that too far because that's a whole nother topic for another day. Okay, let's get to the components of a boiler. This is a hot water boiler. Now the graphic shows red for the water, which it probably would have been a better choice if it was blue, but
Hot water.
yeah, I'll just say it's hot water. So this is your water boiler. Okay, your hot water boiler. This is your supply coming in, or your supply going out, and your return coming in. Okay, imagine this pipe goes out to your building, does all the things at the radiators, heating everything, and then comes back cooler, because when it goes through a radiator, there's a temperature drop because you're moving the hot water potential into the room to heat the air. So that's your typical arrangement. This shows a compression tank. Okay, we'll start from the top. And water will expand as it's heated. So it has to have a place to go. If you didn't have this compression tank, you'd probably be popping what this guy is, which is a relief valve. Okay, you need a relief valve on every boiler system has to have a relief valve. And sometimes it's called a T and P valve, which means it's temperature and pressure. Sometimes it's just pressure. Okay, but either way, for sure you need a pressure. And basically what happens there, if the system for some reason gets overpressured before you start leaking through your pipes or blowing radiators or whatever, this guy will pop and he'll dump the water out onto the floor or down a drain or whatever. And that's what he's for. He's a safety device designed to relieve pressure in the boiler. Now, on a maintenance side of this thing, is if you read the manual of the maker, which you probably won't have, they're going to say you should open that up once a year to test it. Because what they want to do is they want to make sure it's not clogged or plugged up or something like that. Problem with that is sometimes when you open it up and you go to shut it, it doesn't shut off tight because debris or whatever gets caught between the seat, and now you got a leaking valve that wasn't leaking before. You know, so the manufacturer says yes. I have to say yes. I'm just letting you know you might have to buy a new valve afterwards.
Can I ask you a question? Compression tank, well, you just mentioned it has to be drained every year, right?
There's a difference between a compression tank and a diaphragm tank. A compression tank, yes, you are 100% correct on that, because here's what happens. In a compression tank, there's no separation between the air and the water. The air and the water are touching each other. And over time, it's not unlike in a plumbing where they have the little water hammer. What are they called? What's that? Yeah, but basically they're just there. They don't go anywhere, but they're just there to catch air. And what that does is that stops it so when you turn your faucet off, it doesn't go bam, 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 from water hammer. Those are cushions. The air cushions this fluctuation in pressure on the water side. However, over time, that air gets absorbed into the water, and the water slowly creeps its way up. It takes quite a while, but over a long period of time, it could eventually fill. And here's what's going to happen. If you waterlog your compression tank, you now have no way of knowing the tank's waterlogged. The only way, the telltale sign that it is now your relief valve starts popping. Because the water has nowhere to go, and it's going to go through the path of least resistance, which is your safety relief valve, which is designed to take that. So that's how you know. If you pop in relief valves all of a sudden and you weren't and you don't know why, I would look here. I look at your compression tank, because what you just mentioned is a compression. Sorry, I thought I turned that off. So they do have a means where you can drain it. And basically what you're doing is you just drain the water in it to get it back so there's air in there, and then you shut it off. And then the water will naturally back up to it and fill it. There's actually a device that Bell & Gossett makes that only drains it to it. It has a little standpipe in there. So it only drains it so far, and then it stops to drain.
Hold on. Now, let's say I drain all the water from it. And then, of course, I shut down the whole water supply and drain it completely. And then when I open up the water supply, and of course the water is drained in the tank, and the water goes back into the tank. I can hear it.
Yeah.
That's normal? I thought something was wrong.
No. The tank typically is gonna be about half filled. That's okay. That's designed, and if you you might have a fitting that actually is allowing that water to go in, that Bell & Gossett makes. It allows it in, and it also allows it out.
It's not easy to drain this thing. What I am doing, I'm putting a tubing adhesive, so
Well, why are you draining your hot water system?
because I thought I had to once a year.
No, not on a hot water system. You don't need to. No.
You save my time.
Yeah, no. Because the problem with draining a hot water system is you're draining all the water throughout the building, and now you got places where water can get air pockets, and you got to get all that air out, and lots of noise. Do you want another hat? Yeah, you only got a baseball cap. You want a stocking? For asking a question? They're all any color you want. Henry Ford. Here, why don't we? Yeah.
We had our heating guy come out, and he did some work. And I'm not sure if this is too detailed to answer right now, but anyway, after he left, he had said we needed some maintenance. And after he left, this is in spring, our vents, there's a basement loop, and the high point of each loop needed a little air vent thing, and those things started to leak that night, and then so it caused some plaster damage and stuff. And we never got a satisfactory answer from him on what happened there.
Are they? Is this a water system?
It's a water system. Yeah, hot water system. Yeah.
Yeah. See, this is the same problem. And it's with the relief valve. It's same issue. Debris.
That valve didn't open. It was the.
No. I'm saying this is the reason when this valve opens and closes, debris gets caught between the seat, and it sometimes can leak. That air vent has a little float in it,
Yeah.
and there's a little needle and pin that goes up and down. And sometimes when it drops down, and it's because the water's leaving, it's letting the air in, while it's draining. Now when you're filling, it's doing the same thing. Now it's letting the air out until it gets to that point, and then the float seals up against the seat. If there's any debris or anything like that, you can get a leak, and it can get a little trickle.
Afterwards, could I ask you a little more question on that?
I'm going to actually go over air vents, and I think you'll actually understand it a little better if I get into it. Yeah, right. So moving on, low water cutoff. A low water cutoff comes in several flavors. This is a float type low water cutoff, and what it's doing is it's piped in so that it knows what level of the water in the boiler. In this case, it's all the way above in a hot water system, so the whole low water cutoff is flooded with water. This one has a float that moves up and down. If the water level drops, the float will drop. It's wired to the burner, and it'll shut off the burner so your burner will not run. It's a safety device. The way you test this is this little blowdown valve. You open this little blowdown valve. Now, unfortunately, on most residential systems, you're probably not going to see one of these. You're going to see a probe type low water cutoff, which is just a single probe that goes into the water, and it's touching the water, and it uses that conductivity of water to know that it's in water. They typically will have a test button, okay? Some of them don't. And in some cases, the only way to test that is literally just to drain the whole system, which is a real pain in the butt. But that is the only way to do it, in some cases. And it's just kind of depends on the way it was piped, type thing. This is your inlet water. You usually will have a makeup regulator that actually lets the water in. It's usually set for like 12 psi or whatever. So if the system water on the boiler side drops low enough, it'll let the city water in. And that's about it on that. Steam. This is a steam boiler. Here's the low water cutter probe type that I was talking about. It's a little probe that actually sticks inside the heat exchanger. And as this water level comes up and down, it senses the presence of water. In this case, what this low water cutoff is it's wired to the burner. So if water drops off the probe, shuts the burner off. Because now your water, the manufacturer has a recommended minimum water line somewhere marked on his boiler. Every boiler maker has it. If that water gets below that, he does not want that burner running. They want you to rectify that and get water back in the boiler, okay? And that's what this probe type low water cutoff is doing, is it monitors that water, and once it drops off, it shuts the burner off. But now you're like, well, I got no heat. Well, it's also wired to a water feeder. So when it shuts the burner off, there may be a time delay. So bear in mind, it's not going to happen instantaneously. And some of them are adjustable time delays. So they can actually change it. Typically, it's about 15 to 30 seconds before it's going to say, okay, I truly am out of water. Now I'm going to turn my water feeder on and let water in from the city. Because steam systems do lose water over time. It's natural. You can't stop it. So now this water feeder is going to turn on, and then it's going to fill water into the boiler. Okay, and then as the water level rises, it goes above the probe. The probe senses that, turns the water feeder on, turns the water feeder off, turns the burner back on, and now you're back to running your system as it's supposed to be run. Water feeders come in different flavors too. Some of them are electronic. Some of them are just like a solenoid valve type arrangement. They don't have any brains. Some of them, like the Unimatch water feeder, has adjustable time delays. And the reason they do that is steam systems are notorious for delay returns. And a delay return means I'm making steam, I'm sending it out into the system, it's hitting my radiators, it's condensing back to water, and it's working its way back to the boiler. Now, sometimes it gets stuck. And for whatever reason, it just can't flow smoothly back to the boiler, but it's slowly working its way back. You don't want to turn your water feeder on until that condensate has a chance to get back to the boiler. If you turn it on too soon, it'll turn off the water feeder here, but then more condensate comes back, and all of a sudden your water line starts rising. So now you got a high water line. A high water line is bad because you get an effect called priming. So as the boiler starts firing up and boiling, you actually get water getting sucked up into the system rather than steam. And that water now creates more condensate in the and then it just keeps repeating itself until you can actually start compromising the system and you won't have heat. You could just got too much water and you flooded the system is basically what happens. So that's why those time delays are there. I will warn you though, depending on who installed them, you have to hope that they knew what they were doing, and you don't want to adjust them. Leave them where they are. And this is what I'm talking about when I talk about a steam boiler. First thing that happens when there's just air in the system, as this boiler starts steaming, it allows steam to come out. Okay? There's a dimension A that the boiler manufacturer will reference in his literature. It's about 18 inches. And the reason you need that is as you heat up this water and it turns to steam, there's pressure here. So there's pressure pushing down on the water line, but there's pressure pushing up, and that's what pushes the steam out into the system. If you don't have this dimension properly sized, and they size it by the way they pipe it, what it does is as this condensate picks up, it creates pressure that allows the water to get pushed down and pushes the water level up. Yes, I think that's another term that they use for it as well. But we just call it dimension A. And the only thing we're saying is you have to have it. in order for the system to work. Or, you won't get the condensate back. Now we're talking vents. We already had some conversation about venting. Steam systems vent cycle a lot more than water systems do. A water system, your vent, if you get a little air slug that goes through, it might vent. If you drain it and you're filling it up, it's going to vent. But for the most part, it sits there and does nothing except stay shut. A steam system's constantly cycling. The vent's constantly cycling on and off. Because what happens in here is there's a little float in here for water, so if water gets in it, it's going to shut off. But there's also inside the float, it's filled with alcohol, an alcohol mixture. And what happens with that is as it heats up, the alcohol expands. And there's a little diaphragm at the bottom of the float. So when there's just air, it's too cold, the float won't expand. However, when you get steam to it, it expands and it shuts off because in the meantime, while it's just air, it's getting rid of the air. You don't want air in your system. But once the steam hits it, you want to shut off because you want to save your steam. And that's how a steam vent works. All right, so that's kind of how the difference between steam and water. How many people have steam systems here? How many have water? How many have both? Okay. All right, because the seminar was labeled water, but I like to cover both because in this area we see both. Yeah, they actually will break the vacuum. That's what their function is as well. Do you want a hat? What do you have so far? Which one? Ball cap? Knit?
Yeah, no, give me the ball. No, give me the ball cap.
Can you pass that? If I forget to give you a hat, if you ask a question, claim your hat. I got plenty. So let's get a little bit into the maintenance side. Housekeeping. Your boiler isn't a clothes rack. It's not meant to have clothes on it. It's not meant to have clothes near it. It's not meant to be used for storage, for your Christmas decorations that you're going to use at Christmas time. It's meant to be left clean and clear because one, it needs to breathe, and two, it gets hot. So ventilation. If you have a boiler or water heater in a closet, which is not uncommon, it needs air. It needs to breathe. You shouldn't have it. It shouldn't be in a sealed up closet because that's the absolute worst thing in the world for any gas-fired appliance. They need air unless it's sealed combustion, which means it's pulling the air from outside and then dumping the flue gas back outside. So it has a means of giving itself its air. If you do not have that, the doors need to be louvered because you're pulling air from the inside of the house in order to fire that. So do not, as much as people want to hide their heating equipment so that no one sees it, you need to let it breathe. It needs the air. Leaks. Well, hot water systems aren't supposed to leak. Okay. Steam systems naturally leak, from venting, but they're not supposed to leak either. Yeah, okay. They return, everything leaks, so you want to try to find them if you can. One, you're going to be using a lot more makeup water. And the problem with freshwater makeup is it brings in all the chemicals that come with that, particularly calcium, which then coats and covers everything and sticks to everything. And that's what can cause it can plug up pipes, it can plug up heat exchangers, it can cause a whole lot of problems. If you suspect you have a leak, you can put a water meter on your system to see. It's a little expensive, but it's probably about the only way to find out whether or not you truly have a leak. On a steam system, your water feeder is going to turn on periodically. That is normal. Very normal operation, so you should expect fresh water to come in. And that's where we get into a little bit into water treatment. I'm not going to go into different types of water treatment, different manufacturers that are out there. All I can tell you is this, is if you have a system that's been functioning fine for many, many, many years, introducing water treatment may actually hurt you rather than help you. because usually those additives are going to be something used for cleansing or removing calcium and stuff like that, which is a good thing if you have a newer system. If you have an older system, what can happen is now you remove that calcium, and that's about the only thing holding those pipes together, and guess what? You got leaks popping out all over the place. So it's a double-edged sword. I say water treatment is good, but you got to be careful on really old systems because you can actually get yourself into more trouble than it's worth. So be careful of that. And
hot water heat, there's no water treatment. Recent maintenance guy said, this is my mother's building, another building, said that there was some repair he needed to do, so he drained the water. He said, but I really don't want to do this normally, except we have to here. Was he right there that he, that if, except for fixing a pipe, you shouldn't change the water, meaning drain and replace the water?
Unless the water is filthy and dirty looking and stuff like that, you really don't need this. You don't need to flush hot water systems like on a regular basis.
There was no water treatment though on this system, so there was no cleaning of the water. That when you came straight in from City of Chicago water.
I just drain a little bit out and look at it.
Yeah.
If it doesn't look terrible, and I'm not saying it has to look like drinking water, it could have a stain to it maybe, but if it's fairly clear and not really dirty and muddy, I'd leave it alone.
Okay. About how often change water then? Flush and change the water from the system?
You should never have to.
Should never have to. Okay.
Because you got to understand, when you put new water in there, you introduced all those new chemicals, and you're actually going to make things worse.
Yeah, he mentioned that. We had to because of a pipe.
Yeah, well, that happens. When you're doing maintenance, you have to. So obviously, keep trash and debris away from the boiler. I talked about it's not your place to keep your Christmas decorations, and the other thing, you have to be able to get to the controls. You have to be able to see the stuff. So if it's all blocked and covered with things, how are you going to see if the thing's even working right? If you can't see the water heater or the boiler. So, I guess I beat this to death, but you'll be amazed when I walk into places and all the crap they got piled around their water heater. All right, and ventilation, probably, oh yeah. I talked about ventilation. I think I beat this to death already. They need combustion air. They use air for combustion. Don't seal it up in a closet. Well, that actually is true. I mean, depending on how sealed the basement is. But the rest of the stuff, I'm going to move on. Leaks, they obviously increase operating costs. You just water down the drain. It's water you're losing. Underground, sometimes there's piping that's run underground. That's really problematic because one, you probably don't know it's leaking, and two, it's probably pulling in dirt and grime or whatever that's in the ground. So that you really got to be careful of. And the unfortunate thing about that is if you have an underground leak, besides busting up the concrete and getting to it, you're in trouble because there's really no easy answer to that. If you're pretty comfortable you got a leak underneath, it's going to be expensive. Well, yeah, finding it is, that's what I'm saying, if you truly have determined it. And the leak can damage other components by bringing all the dirt and all that, and it's the system, you want to keep it as clean as possible. So, if you have somebody come in and do your servicing, or I don't know if you guys try to service your own equipment yourselves. I personally, unless you really know what you're doing, hiring somebody, this is where you hire a professional to service your equipment. It's really a good idea. One is if he's going to be checking your emissions, the quality of your emissions. My exhaust gas analyzer that I have is almost $3,500. Okay, but that is a commercial grade, higher end analyzer. I've seen them as low as 1,000, but even so, it's 1,000. That's not cheap. So they should have that. Now that's the reason I bring that up is if you got somebody is going to service your boiler, you might want to ask them, what are you going to do? Ask them, what are you paying for? You have a right to know. And one thing you want to make sure he's going to do is, in the end, he's going to check combustion and verify that the combustion is within the parameters of the Boilermaker. But besides that, he should be inspecting the gas piping, making sure that's fine. The ventilation, the stuff around the boiler, not only inside the boiler. They should inspect and clean the heat exchanger, inside and out. Now, inside's a little more difficult with a water boiler, so normally they won't do that, and that's not uncommon because it's hard to do. You don't want to drain down the system. You're really going to create more problems. The outside, though, the heat exchanger side, typically they can clean because it gets sooted up and whatnot because it's exposed to the flue gas. So there you want that to get cleaned because that'll help the heat transfer and it'll help the emissions on the boiler. And then they're going to check your safeties, at least as best they can, and the operating controls to make sure that they're functioning right. So that's basically what they should be doing when they come in and when they say they're going to give it a tune-up or whatever terminology they're going to use for the maintenance. You want to keep records of that. Now, you're not going to do a daily maintenance check on your piece of equipment, but if you're down there and it's in the wintertime, just taking a little look-see at it, it doesn't hurt anything. And, this way you know that, hey, well, it seems to be, I don't see anything, I don't hear any noise. It's like your car. When you're driving your car, you notice, hey, something's different. I don't recognize that noise, or it feels different, or something like that. Same thing with a boiler. Just walk by and just take a look to make sure that it's just doing what it's supposed to be doing. Annually is when you get the guy to come in and look at it. Yes, sir.
I was always told that it was good once a week to go in and just hit the flush valve for a minute just to and it's usually pretty nasty water that comes out. But you're saying not changing the water, so now I'm wondering.
No, you're talking steam. I was talking hot water.
Oh, that was hot water, not steam.
A steam boiler low water cutoff, and I was going to get into that a little later. A steam boiler low water cutoff does require blowdown if it's float type low water cutoff, not a probe type. A probe type typically will just have a button to push.
Okay.
A float type has a blowdown valve, and you are 100% correct. During the heating season, giving that a flush once a week is a good idea. It does introduce new water, which is bad for the system. We've established that. But that sediment can settle in the float bowl of the low water cutoff. So if you think about it, it drops down following the water line, and when at a certain point it shuts off the burner. Well, if that debris keeps building up, you can drop down and hit the debris before it turns off your burner.
That'd be great, right?
And now your low water cutoff isn't doing anything. And that's why they do blowdown.
Gotcha. Thanks.
You do it a lot more often than once a week?
No, not on a residential application. I would actually say once a week is if you got kind of crappy water. But really, once a week is more than sufficient.
What's the minimum color that you're supposed to look for when you do discharge the water?
Clear is
Clear?
nice.
Till it's clear.
Will it be? No.
Yeah.
But that's why you're flushing it. The initial flush will be, it's a dirt leg. It's a natural dirt leg. So it's going to have sediment. So you're going to see, actually, it's okay to see junk come out because that means you've been successful. The other thing, too, and this is where some people it's a little counterintuitive. You do it when the boiler's running and firing.
Yeah.
Don't do it when it's just sitting there. You have no pressure. All you have is the weight of the water flushing. You want that pressure that's inside that. Be careful now, it's hot. So wherever that water is going to go, and it will burn you. So however, you need that heat and pressure to get the good cleaning and a good flushing action. So it's counterintuitive because no one wants to do it because it's not an enjoyable event. It's not something you look forward to every week, I'm sure.
ball valve, in relation to the ball valve and the, let's say, surging, how would you be able to, if you've changed the ball valve, the intake valve, how would you be able to prevent the surging in order to make sure that the valve didn't remain in an open position then? If you know.
Are you
even
talking
with-
the fill valve?
Yes.
Well, the fill valve should be shut after you're done filling the boiler. If you're getting surging has nothing to do with your ball valve. It has the only thing that causes surging is there's a film on top of your water line, typically oil, believe it or not, or some debris. And what that does is that creates it's like locks in the steam, so the steam has to fight through it, and then it goes whoosh, and then flies out. The other thing with surging is sometimes when you increase your pressure in your boiler, because people think I'm not getting heat to the furthest terminal, so I need to increase pressure, which is wrong. But that'll actually create a pressure difference in a tilted water line. And the tilted water line actually is what you're seeing when it's surging because of the pressure. The water line should be fairly stable while the boiler's running. Now, I'm not saying it's going to be flat and calm like, on Golden Pond or anything like that, but it is going to be, it shouldn't be bouncing up and down. And if you got a steam boiler, you should have a sight glass so you can see that. I mean, you may get it bouncing a half inch or something like that. That's typical. But if it's bouncing up and down in that sight glass, that's when you do want to drain it. But here's the deal. You want to skim the boiler first. I don't know if you've ever heard of skimming. And what that basically is there's a pipe on that steam boiler that when the guy first installed it, he put all this new pipe in there. It has all this he cut pipe and all this, and all these cutting oils and debris and flux or whatever is all in that water. I mean, you can't get it all out. And it's going to work its way back to the boiler eventually. And that gets on the water line, but typically it'll float. So what you do on skimming is they actually turn the boiler on and let it run and let the boiler water, the top of it flow. It's right at the water line is where the skim pipe's located, and that'll skim off the crud off the top, which will help stop surging. That's why they do it when they first install a boiler, by the way. It'll skim for 4 or 5 hours to get all that oil out.
When you talk about surging on a steam boiler, we're talking here, right?
Right.
How do you know that's happening? I've got a banging noise that's routinely happening as the boiler fires up in the morning. I believe it's in the boiler. I've talked to many people on this. I've gotten multiple theories. I've done a lot of things like making sure the radiators are all pitched so that the water's draining back in.
Banging is usually water hammer, typically.
And
But it could be metal expansion as well, making like a ticking noise or whatever. But if it's banging, that's usually you got something water locked up somewhere that's not getting back.
is it possibly in the pitch of the return pipes?
How long does it last?
It usually just does it, depending on how much the boiler is firing up, depending on the weather. It can be like 4 or 5 really loud knocks over the course of maybe 5-10 minutes. It doesn't do it constantly, but it'll.
Well, if it's first firing and you're seeing it, it's in your near boiler piping. It's not out in your radiators. It's not out, and you got to find out where the noise is coming from. Odds are it's in the mechanical room and the piping, and that means your near boiler piping might have a pitch problem, where the water is not being allowed to get out. So daily, basically just look. I mean, you can't always look at the pressure or temperature gauges just to see that, you got temperature and you got pressure. One thing about steam boilers, though, is just so you know, is if you're not getting heat to your furthest radiator, increasing your steam pressure is not likely to solve your problem. They're designed to operate on half a PSI. I mean, they're not meant to be 2-3 PSI typically. You don't typically need that. Usually, if you're not getting heat out to your system, you got a condensate management problem, where there's water condensate getting trapped, blocking those radiators, or you got radiator vents that are plugged up, blocking the air to get out. Because if your radiator vents do not let the air out, those radiators will take a long time to get warm, if they get warm at all. So you got to make sure Air is the enemy in a steam system. Condensate can also be the enemy because it blocks the steam. But really, air is the big enemy in a steam system. Obviously, you should check to see the boiler's not an alarm. Boilers nowadays have lots of safeties, so they can protect themselves. So those alarms are meant to obviously let you know that you got a problem. Here's where we say flushing monthly on a low water cutoff is fine if your system's fairly clean. If you got a dirty system, here's the way to figure it out. You flush it in a week. A week later, you flush it, nothing comes out. Wait 2 weeks. Flush it in 2 weeks. If nothing really comes out that's dirty, you can extend it. If you flush something out and dirt's coming out, guess what? Now you're back to the 2 week cycle or the 1 week cycle, depending on how, because you do have to understand that over time, unless you have like some source of dirt getting into the system, it should start clearing out. It shouldn't keep constantly having to do that. If you constantly have to do that all the time, you got a pretty dirty system, and that dirt's not only going to get in the boiler, it's going to get other places that are going to cause you fits. We talked about the relief valve. We say exercise the safeties. Most residential safeties, you don't really have a lot you can do there to exercise. So this is kind of a commercial thing where there's more safeties to check. But on a residential application, there's really not much except some low water cutoffs might have a test button. One thing you can do is when you flush your low water cutoff with the thing running, if you flush enough water, it should turn your burner off. And now you've tested your low water cutoff too. So you get I tell you got to do it when it's running. It's not going to run for long because once you flush that out, it should turn the burner off on a steam system, and that's normal.
That also checks your low water too.
Yeah, and depending on the time delays, it could turn your feeder on too, which is what you're going to need anyways because you just pulled water out of the system. Very good. Would you like a hat?
I'd like a hat.
Sure.
What do you want, a cap or a stocking cap? Ball cap or stocking cap?
Stocking cap.
Okay.
Thank you.
Who else said they wanted a hat? Ball cap?
Stocking.
All right. Annually, this is where you actually get into the real nitty gritty. Now, I can tell you right now, most of you folks, if you're not an HVAC person, you're probably not trained to be doing this. So this is where you want to have a qualified technician come in. And, you also got to be careful. Sometimes the best price isn't always the best guy. So be a little careful who you pick. I can't tell you who to pick and who not to pick. All I can tell you is ask him what he's going to do. And now you guys have a little bit of knowledge to say, okay, what are you exactly going to do? And then you can decide, who you want to go with. So you can see all the things that he's going to be doing. He's going to be checking your flame. He's going to be checking your electrical wiring. Obviously, he's going to check to make sure that there's no combustibles near the piece of equipment. Gas piping, room ventilation. These are all things the guy should be looking at. Because if he knows this can affect his combustion, he'll look for it. If he's going to walk in and walk around your boiler, turn it off, and maybe blow some of the heat exchanger out and call it a tune-up, well, you're getting what you paid for.
Part of this is tested by the expensive instrument.
$1,000 instrument is what's needed for this, right?
To adjust combustion, yes.
Just combustion, which is flame and ventilation.
Right.
And,
Atmospheric boilers aren't as sensitive to it as modulating boilers.
Okay.
To emissions. But atmospheric boilers are exactly what they are. Atmospheric. They require atmosphere to run.
So if it's checked once, how often would it need to be checked? If it's an atmospheric boiler, which we have, would you really recommend every year for that still?
Yeah, we always recommend annual maintenance. It's always a good idea. I mean, I don't know what they charge around here, but it's not a huge expense, and at least you've had somebody look at that piece of equipment, you know, because if he's doing what he's supposed to be doing, he's looking at more than just your combustion. He's looking at the whole, the way it's installed. Because when I walk into a boiler room, I look at the boiler, but I'm looking around at everything. And on modulating boilers and stuff like that, or even, you know, atmospherics, you know, he's going to be checking your pilot light. He's going to be checking your igniters, making sure that he may actually, some boiler makers recommend replacing them annually. Residential, not as much. Commercial, more. You know, where you actually go in and you replace the igniter or the flame rod or whatever annually. So if you really think about it, for the expense of replacing it when you don't need the boiler to at Christmas Eve when the boiler goes out, because it always goes out on Christmas Eve, you know, now you're really going to pay to have that thing.
Are all these things you're showing us now true for both steam and hot water systems?
Yes.
Okay.
But here, bear in mind, I blend everybody. So this is probably the absolute Cadillac of maintenance where you're going to, you know, your manual, if you still have it for your piece of equipment, and if you don't have it, the internet, Google it, because you can get it right off the internet, the manual for your particular piece of equipment. It'll lay out exactly what they want you to do, and that's what you should be following. I'm just saying, as a general rule of thumb, these are some of the things that I feel are important that they should be checking for. And obviously, they're going to be checking the heat exchanger, clean and check. They're going to be looking for leaks. You know, I mean, I don't know. I mean, you can use your nose, but I mean, if there's a gas leak, they have equipment to test for that too.
I was told to overfill the steam.
over the top to see if the sections are leaking. Now, that kind of contradicts the water.
He's talking, the reason they're saying that is because sometimes the corrosion can happen right at the water line. And often you won't see it, but you're going to see it with the steam coming out of
I
that.
had it at the top. It was at the top of the boiler.
Yeah, because you don't necessarily see the steam if you're not looking for it.
Right.
You know, and that's what they're talking about there. You know, and plus, you know, those boilers, they last like 25 years though, or boilers. I mean, they'll last a long
Yeah,
time.
but when they go out, they go out.
Yeah, on Christmas Eve.
Yeah. Or 5 below.
Right. They'll also, they can have means of measuring. They have what's called a manometer, which can measure real low pressure, which is like gas pressure. So they make sure that you got sufficient gas. Because in Chicago, I don't know so much around this area, but Chicago, there's areas where the utility will only promise 4 or 5 inches of gas. That's why these big buildings downtown have gas boosters and stuff like that in order to run their systems during peak time. And that's when you need the gas, is, you know, when everyone needs the gas type thing. So you want to make sure you got the right amount of gas pressure coming into your building or into your. You also want to check for too much. You know, because like when a manometer runs in inches of water column, okay, so 28 inches of water column is 1 pound. You know, so they run around 14 inches as a high end. So that's a half a pound of pressure. That's not a lot, but you need that. Your flue, often ignored, very dangerous. I am not a big fan of plastic flue. The Boilermaker, one guy started it and then everybody jumped on it, and now everybody says it's okay for smaller units. But usually nowadays, if you're going to use plastic, it certainly is not on an atmospheric boiler, because an atmospheric boiler needs B-vent. Metal, B-vent, not plastic. It'll melt. The modulating higher efficiency type equipment can handle plastic, but usually what they'll do is they'll make the maximum set point low enough so that they know the flue gas temperature won't get high enough to melt the plastic. And they program that into the boiler to protect it from melting the flue. But if you think about it, they're protecting it from melting the flue. How about just use metal? You know, I mean, the expenses, unless unless you own a high rise and you got to run it up 30 feet or 30 stories, you're talking a small amount of money. I just, when they started coming out with plastic pipe, I was like, okay. All right, I got 5 more minutes. So So I'm going to have to move along here. This is just the heat exchanger. This is a little coil type heat exchanger. This is actually a stainless steel coil. Little boiler, modulating, higher efficiency. It can be you can use the same philosophy on other boilers. Sometimes what they'll do is rather than I suggest you can use water, but a lot of times they'll use like nitrogen because they may not have a drain nearby and you don't want to make the big water mess. So that's okay. It's compressed nitrogen is what they use to blow out the heat exchanger, and that's not uncommon. What you want to make sure they're doing is just looking at it. After they blow it out, they look inside to make sure it's cleared.
Excuse me, where's the heat exchanger? Where's the heat exchanger?
In the boiler, their boiler's a heat exchanger.
For hot water or for steam?
Both. The heat exchanger is the big part of the boiler. That's
So
the
where's
water.
it at?
It's
On the bottom?
No, it's most of the boiler is your heat exchanger.
Oh, the whole thing.
That's just a term. The boiler itself is one big heat exchanger.
Okay, so
I don't know how to explain it
how
except
do you look into a boiler? Because it's a big thing you just said.
you can take the covers off.
Everything above the flame.
Yeah, you can.
Oh, so you can see the burners and then okay.
Yeah,
That's all you have to look at. Okay.
yeah, and they can inspect. They can look either underneath, or sometimes they can pull the burner out and look inside,
Okay. All right.
depending on the type of boiler.
Thank you.
One other thing about combustion air, you got to be careful of what's in the air. I mean, here again, this is more commercial, but like if you have a pool, you don't want chlorine around that combustion air. You don't want to suck in chlorinated air that has chlorine. You can smell the chlorine, like a pool or something that's nearby. Not typically you're going to find in a residential application. Refrigerants, you got to be careful of because they can be super corrosive to heat exchangers. And here I was just saying, typically on the smaller one, they'll brush and rinse with water. On a higher efficiency boiler, there's usually a condensate drain, so it's going to drain out the water. On an atmospheric, you cannot do it this way. You have to just use probably nitrogen and a brush. This is what I'm talking about when you can pull the burner. The heat exchanger is what's around it. But this, like I said, is more of a higher efficiency type piece of equipment rather than just your cast iron flame underneath. You can see the flames type thing. Different burner assemblies. But these, like I said, are more your modulating type. What I really want to bring out, this is that piece of equipment that I was talking about, the analyzer. And they do stick it right in the flue just past on the outlet of the boiler. That's where they're measuring. So they'll drill a little hole, and so don't be upset if they drill a hole in your vent, because they need to drill a hole to stick the analyzer in. But then they'll put a piece of tape over it or something to plug it up so that the flue gas doesn't get into the room. But that's where they're actually drilling a hole and going into the flue. And they're basically measuring O2 or CO2. And they can measure other things too, but that's for the most part. And the manufacturer will have a parameter that they want to operate within, and then they're just checking it. Some of your atmospheric boilers, the only way to adjust that is to clean the burner and clean the heat exchanger to get the air flowing properly, because that's what will change the combustion process, because it just doesn't have enough proper mixture of air and fuel for proper combustion. On modulating burners, there's adjustments that they can adjust the gas and air mixture to precisely tune it in. And that's why with a modulating burner or higher efficiency type burner, that's why they can get the higher efficiencies out of it, because they can control that burner a lot better.